welcome back. In this video, we are going to take a look at one of the gas laws, Gay-Lussac's law. So Gay-Lussac was interested in studying the relationship between pressure and temperature in gases, and what he discovered is that pressure and temperature are directly proportional to each other. That means when one increases, the other increases. So if temperature is increased, pressure will also increase. And this is because temperature is a measure of the average kinetic energy of the particles. So if we're increasing temperature, that means that we're increasing the average kinetic energy of the gas particles. And when that happens, we have more collisions between the gas particles themselves and between the gas particles and the walls of the container, which increases the pressure of the system. So Gay-Lussac's law says that if we keep volume constant and the number of particles constant, temperature and pressure are directly proportional to each other. So if we keep volume constant and the number of particles constant, temperature and pressure are directly proportional to each other. And we can see that relationship on the graph as well. If temperature is increasing, then pressure is also increasing. So let's look at an example. If I had two containers of equal volume, so we'll just say the volume is 1 liter for both of these, and an equal number of particles as well, then we should see that if we increase temperature, the pressure will also increase. So let's say in our first container, the temperature is 100 Kelvin and the pressure is 1 atmosphere. And here's our particles moving around. Say we have 3 particles. And our second container, let's say that we increased the temperature to 300 Kelvin and pressure increased to 3 atmospheres. What we should see is that because we increase temperature, which increases the average kinetic energy, our particles are moving faster, they have more energy, so they are more frequently colliding with the sides of this container and with each other, which increases the pressure of this system. So if we took the quotient of both of these scenarios, we're looking at a quotient P1 over V T1 because this is a direct relationship. They're directly proportional to each other. So if we looked at both of these scenarios, they should both equal a constant value. So if we look at our first scenario, we have 1 atmosphere over 100. And in our second scenario, we have 3 atmospheres over 300. So this is still just equal to 1 over 100, a fraction, and this we could simplify as well to 1 over 100. So pressure and volume are directly proportional to each other, and in any scenario, as long as we're keeping volume constant and the number of particles constant, P over T will equal a constant value, which allows us to have the equation P1 over T1 equals P2 over T2. And in this scenario, both sides of our equation would be equal to 1 over 100. So let's try an example of using Gay-Lussac's law. Let's say that we have a tire that has a pressure of 1.88 atmospheres at 25 degrees Celsius. What will happen to the pressure if the temperature increases to 37 degrees Celsius? So let's write down what we know. We know that P1 is equal to 1.88 atmospheres, and we know that T1 is equal to 25 degrees Celsius. But I cannot use 25 degrees Celsius in my equation. I do have to convert that into Kelvin. So I'm going to add 273, which is equal to 298 Kelvin. My T2 is equal to 37 degrees Celsius, and I also need to change that into Kelvin, so I'll add 273, which is equal to 310 Kelvin. Let's write down our formula. We have P1 over T1 equals P2 over T2. We're solving for P2 which means we need to move our T over to the other side. So P2 is equal to P1 times T2 over T1. So we should have 1.88 times 310 over 298. Our units of Kelvin cancel out. We're left with atmospheres, which is what we want for pressure. And this is equal to 2.0 atmospheres. So we can easily solve for the missing variable if we're given the other three, as long as we rearrange the formula. And just don't forget that your temperature has to be in Kelvin to use this equation. If you want to know more about other gas laws, make sure and check out my channel. Thank you so much for stopping by.